All right, while you guys open those up, just something so that we're all on the same page. And I know this is maybe not due to your fault. Maybe it's the way that things happen in the 7th grade, 8th grade, maybe even before then, that you're trained where this is okay. But when I give an assignment on a worksheet or something like that, and it's due the next day, it's due the next day. Okay, after that, I'm not going to accept it. Now, the first one I will accept a few days late, okay? But from here on out, I need you, once we give an assignment, handout, even on Math Excel, it's due the next day. And no matter how valid your excuses are, now there will be, for instance, something dramatic happens, talk to me, okay? But something like, I just left it on the table at home, I ran out without my book bag, something like that. Those are things that aren't going to be accepted, okay? So just keep that in mind as we move forward. And the philosophy of that is for several reasons. One, if you're continually doing work that's late, and then next day we build upon that, then you haven't defined or refined your skills that we can build on. Does that make sense? Okay. Also, and I'm not saying that this is the case, but I experience you. I have very limited interaction with you guys so far within a week and a half of school, 2 weeks of school, and I don't know you. So you say you left it. I don't know if you're an honest person, or that you legitimately left it at home and forgot, or if you're just seeing that. And I'm gonna see if you collected it, and then I'm gonna do it. Okay. So that's there. And another thing is I'm trying to prepare you for other courses. But does anybody have a job in here? Okay. If you go to your job and only do half your job, are they going to keep you? No, right? So this class, half your job, I don't want to say half, but maybe like a third or a fourth of your job is the homework, right? Okay? And if you're not doing that portion of the job, you're going to get fired. And what I mean by that is you're going to see a negative response in terms of grades and just acquiring knowledge. You're not going to get it if you're not doing the practice. Does that make sense? Okay, so trying to get you in that mindset when we have due dates, they're due then. If you do bring it late, that's fine. I'll grade it still. I'll give you feedback, but it's not going to go into progress book as a positive grade. Does that make sense? But I'll always give you the feedback that you need. It's just not going to benefit you in terms of a grade. Yes?
Did you get a haircut?
No.
You're lying.
Yeah, I did.
I noticed it before you.
Oh, it fell down.
Huh?
It fell down.
Can I put it back up?
No, that's all right. That one always falls down, so let's just leave it there. It fell down. It must have been during lunch. Okay, so let's start with, unfreeze this. I wasn't in here during lunch.
Where were you?
Down the hallway.
I have a question.
Yes.
Why did you happen to have any other fans?
Any other fans? Nope. You hot?
Yeah, right there.
It's going to get worse. It's going to be real hot this week.
Tomorrow.
We'll be up almost to 90.
It's gonna feel like 90.
Can I bring a big fan?
You should bring a big fan. Why did you suggest it?
There we go.
Why you didn't listen?
All right, so on Friday, we discussed these ideas, right? Talked about the commutative property, the associative property, and then some identities. Okay, I just want to rehash those things real quick. If you remember from that discussion, the commutative property just means that you can move things around and still get the same result, right? Through addition or through multiplication. So what that said in algebra was like A plus B was the same thing as B plus A. That's the commutative property. Now, I'm going to color these things as that and that. Okay? So what we've got here, I've got positions. I got a blue position and a green position on both sides, right? Okay, last class was having some issues with it. So if it's the commutative property, then the objects that are in the blue positions are going to be different. Does that make sense? Okay? So you see how A on the left-hand side is different than the B on the right-hand side, right? So I have moved things around. I've changed their positions, so that's the commutative property. Okay? And we saw examples of that, kind of like, 2 plus 3, same thing as 3 plus 2. We did an example where, like, x plus 5, the same thing as 5 plus x. Okay? The commutative property, to be honest with you, isn't all that useful with just two terms. 2 plus 3, 3 plus 2. Okay, that's not really a big deal. But it's when I have 3 terms, 4 terms, 5 terms, maybe the commutative property makes more sense in those types of examples. Okay? The multiplication property with the commutative idea said is if I have A times B, that's the same thing as B times A. Okay? Again, looking at the positions, that first position on the left-hand side has A in it. On the right-hand side, the first position has B in it. That's different. So we've moved things around. We've got the commutative property existing in it. Again, maybe not the most useful all the time with just integer values, like 2 times 3, we know what that is, 6, and 3 times 2, we should be able to do that and get 6 as well, right? Obviously, these properties are meant for us to utilize to make things simpler for us in procedures. I don't know that 2 times 3 is any simpler than 3 times 2, right? But it is a fact that they're the same, and the reason they're the same is that property. You've seen this with multiplication, like 2 times x. Okay, you guys remember in other classes, like, maybe we could write it that way. Is 2 times, let's say x was 5. Is 2 times x going to be the same thing as x times 2? Yeah. Okay, but what do we call that number out in front of a variable? Starts with a C. Again? Close. Change that N to an E, that coefficient, right? Okay, so coefficient are those numbers out front, and probably 90% of the time, there's a couple times we like to write coefficients in the back. Okay, but if it's a variable like this with some number out front, we like to write that number first. Okay, so 2x is the same thing as x2. That's real. 2x is just easier to say, it's easier to talk about, it's easier to write. Makes more sense seeing it this way than that way. Okay, but those are equal. We just have the practice of writing the coefficient first. The associative property, so when we identify the associative property, we usually use 3 terms to do that. So it's addition, it's A plus B plus C. And if you remember the associative property, it says you're going to group these two, and that should be the same thing as in taking A plus B plus C. And instead of grouping the first 2, you group the back 2. Notice how this is different than the commutative property. Did anything, if I highlight my position, that's the first position. Is that the same thing, the first position there? If I look at that one, that's the second position, right? Is B the second position there? And if I look at the final one, C is the third position, C is the third position. So as we look at those from both sides of the equation, the positions do not change. So it's not commutative. All that changes is what I've grouped, right? And basically what that means is I've restructured the problem so that I use order of operations to do either A plus B first on the left-hand side. On the right-hand side, order of operations is going to tell me to target B plus C first. Okay? Maybe some ways that we've seen that in specific examples is like I have 2 plus 3 plus 7. If that's written that way, I've got to do the 2 plus 3 first, right? Now I've got to add 7. So I got 5 plus 7. I don't like adding odd numbers. I'm weird like that. So what I would do is do this. Kept everything in the same position, but now, even though 3 and 7 are still odd numbers, isn't 3 plus 7 really easy to do? Yeah, 10, and then I add my 2 to it, right? So those are the same. Maybe some reasons why we would do this algebraically. If I had 2 plus x plus 3x, and I had grouping around there for some reason. Well, I can't combine those because one has x in it and one doesn't, right? Okay, remember, x is just a number, I just don't know what it is. So I don't know what number to add 2 to. Okay, but if I do this, I go 2 plus x plus 3x, and I group the x plus 3x. Can I rewrite that?
Yeah.
I can rewrite that as 4x, right? I can actually do that addition. So that's kind of the reason why we have that ability to group things. Okay? With multiplication, it's the idea if I have a times b times c and I want to group the first two, that should be the same thing as taking a times b times c and grouping the last two and doing that multiplication first. So you've seen that with like 2 times 3 times x. If I have it written that way, okay, maybe it makes more sense because I don't know what x is, so I don't know what number to multiply by 3. If I do this, if I go 2 times 3, group those, and then multiply by x, does that change things? Can I rewrite that now as 6x? And that's, you guys talk about maybe in other classes, simplifying and that kind of thing, knowing that I can take 2 times 3x and get 6x. But that's the reason why we can do that. It's like we can regroup the 2 and the 3, do the order of operations, get 6, and then multiply by that unknown value of x. Okay. The next thing is the identity properties. Okay. And basically what it means is you start with some number a. What can I add to it so that I get back a? 0. Okay. So that is 0 is referred to as the additive identity. Okay. So if I started with 3 and I wanted to get 3 back, I'm going to add 0 to it. Okay. The multiplication identity. If I started with a, and I want to multiply it by something and get a back, what do I need to multiply by? 1. Okay. Now that one there is probably, in terms of the work that we're going to do, that one is the most important. Okay. A lot of times though, we're not going to multiply by 1 just like that. Maybe we multiply by 2 over 2, or maybe we multiply by 5 over 5. Because those are equivalent values of 1, right? Okay? And those might generate common denominators and that type of stuff so that we can actually do some of our algebra. But understanding that no matter what version of 1 I multiply by, I'm not going to change the amount. And that's what we're looking at here when we talk about the identity. You don't change how much you have. Does that make sense? Okay? So if I have a bank account that's got $1,000 in it and I multiply by 1, I still got $1,000, right? If I have a bank account that has $1,000 in it and I multiply by 12 over 12, I still have $1,000, right? Okay? It just looks like 12,000 over 12. Does that make sense? 12,000 over 12 is still $1,000. Okay? So those are the kind of things that we'll be talking about. This property is very useful. And just a generic version of that would be 3 times 1 is equal to 3. Zero property of multiplication says if I take a and I multiply it by something and I get 0, okay, what did that number have to be?
Yeah.
0. So we're getting 3 times 0 would give me 0. Sorry. If I took x times 0, that gives me 0. Those are some examples. And then I think the last one we talked about was if I start with a and multiply by -1, what do I get?
-1. Oh, right.
Okay. Now,
I did that the last time, too.
now a lot of us will, and I'm guilty of this all the time, I like to say negative a. A times -1 equals negative a. I think it's more appropriate to say a times the opposite of 1 is equal to the opposite of a. Okay? Because think about this. Did you know what a was? No. A, if we look up here, it said it could be any real number. So if a can be any real number, what if a was -3? Multiply by -1, do I get? Yeah, I get 3, which is the opposite of what I started with of -3. Does that make sense? So that's why I think it's more appropriate. You wouldn't say this is -3, right? That's a double negative. We don't say that. Okay? So this is, I think, more appropriate to say opposite of a. And the reason for that is because initially we don't know whether a was positive or negative. Okay? Okay, so the remaining questions on here or components to this handout are just examples. Okay? Now, I told the last class this as well. I have taken, not something to brag about because a bunch of math classes, you're going to brag about that. But I've taken an endless amount of college math classes. Okay? I've taken all the classes that you're going to take until you graduate high school, right? Okay? I have taught those classes. I've taught some college classes. Okay? And if I were to redo everything, okay, even if I wasn't going to become a math teacher, if I wasn't going to be a math major, but knowing just what classes you have to take beyond this in regards to math to graduate, if I could go back and be in the same seat that you are in right now, I would take this stuff a lot more serious, okay? Because of what the associative properties, the commutative property, these identity properties allow us to generate for other procedures, okay? If we can understand this stuff and remember these terms and recognize these ideas, it makes all of the rest of algebra a little bit easier. And I wish I would have known that when I was a ninth grader sitting in your seat, okay? Because of, 10th grade, 11th grade, now I'm behind the 8 ball in regards to trying to catch up. Does that make sense? Okay, so we always have the question, like, what's that property? What allows us to move things around? And everyone's like, I don't know, it's one of the two, commutative or associative. Well, those are the only two we got. So yeah, you're right, but we got to be able to make sure we can recognize and kind of identify that as soon as possible. Okay? So look at this first one. We're just going to name these properties. Okay? So what allows me to do this over here and get 0? Okay. Multiplication, property of 0. And if you said 0, and I don't know how I've got it written above. Does it say 0 property of multiplication? However you want to write it. However you want to write it. As long as you say multiplication and 0 together somehow, that's what we're doing. Even if you got that as phrase as multiplication property of 0, you just say multiply by 0. Okay? That's encapsulating enough of what's going on there. Okay? Look at that second one. Did anything change? And you're going to see some of this in your homework. I had a lot of questions last period about this. This is position 1. Position 1. Position 2. Position 2. And then position 3. Position 3. If I look at them that way, does anything move position?
No.
No. So is this going to be the commutative property? No. Okay. What changes is the grouping, right? What property addresses grouping? Good. Associative property of addition. Okay. On your homework, you're gonna, a lot of them are multiple choice. It might be a drop-down window for select D and something like that. Let's think about why this is. I don't know what y is. Y represents a number, but I don't know what it is. So I don't know how to add 2.5 to some number that I don't know what it is. Okay. But if I regroup things, can I do that math? Yeah, I can add 2.5 to 28 and get 30.5, right? So that's the purpose. That's the necessity of being able to regroup things. Okay? It makes the simplifying process a little bit easier. Essentially, you guys know how to simplify for the most part. You've practiced that in previous courses. What allows you to simplify is the commutative property and the associative property. Okay? Without those, you can't simplify. There's one more property called the distributive property. Have you heard that before? Yeah. Okay? Distributive property also becomes pretty critical in simplifying things. Okay. What about when I take 10x and I add something to it, and I get back to 10x. I get to what I started with. Say that again? Okay, good. So it's the identity of addition, right? And now a lot of times, and I don't care how you phrase that. What most textbooks are going to call it is your additive identity, or your identity of addition, or addition identity, something of that nature, okay? Most textbooks call it the additive identity. So adding 0 and not changing what I started with, right? What if I start with 4x and multiply by 1 and get 4x? Does that change anything? Okay, the identity property of multiplication. Okay? It's kind of a weird word. We'll call it the multiplicative identity. If at any time, guys, you can't read something that I've written, this thing's kind of hard to write with, hanging in the air. So multiplicative identity. All right, now the next one. There's position 1. There's position 1. Do the terms change? Yes, good. So that's position 2. There's position 2. So because we still have the same sum, right? So we change the order. That's the commutative property.
I thought it was commutative.
No end. No end. Commute.
Oh.
What's next? Commutative property of multiplication. Okay, so looking at that then, now why would we want the commutative property of multiplication? Now, this is saying the same thing over here, right? It's all multiplication, even though there's no dot between the 2 and x. We have that implied multiplication, right? The reason we use the commutative property here is if and I don't have it written this way, but it probably makes more sense to take the 2, the x times the 3, and rewrite that as maybe 2 times 3 times x, right? And now order of operations is telling me to do that first, and that gives me 6x. Do you guys agree that when you see that, you think visually 6x? Yeah. But the reason that we can get 6x from that is the commutative property allows me to move things around, and then looking at 2 times 3 times x, the order of operations tell me to do the 2 times 3 first, I get 6, and then 6 times x. Okay? In mathematics, there should always be a reason why. Always a reason why. Why does 2x times 3 turn into 6x? The reason why is because the commutative property allows us to move things around, and the order of operations it tells me to do 2 times 3 first. And that's the reason why 2 times 3 times x is 6x. Okay. The next series of questions is just that, taking an expression and simplifying it. Okay. Now you might think right off the top of your head, well, I'm going to just go straight to the answer. So everybody sees 5 times 3n. What are they usually going to refer to that as? How are you going to simplify it? 5 times 3n. Okay, so you're going to go 3n times 5. So what's that going to get if you're going to write a final simplified answer? Most people are going to write 15n, right? Well, let's think about this. If I take and rewrite this as, let me get the, so 5 times 3 times n, let's group it this way. Are 5 and 3 like terms? Yes, so they're both integers, right? And we'll talk about what integers are on next couple days. But they are both numbers out of our number system. I can multiply those because I know what they both are, right? So that's going to simplify. 5 times 3 is going to simplify to 15. And then I still got that n out there, so I got 15n, right? Okay. Now, if we think about that, what that means that if I read this, okay, I've got 5 3n's, right? Well, if I have 5 3n's, let's write it this way. Huh? What did you say? You can think of that multiplication right there as distributing. But usually when we distribute, we got multiple things inside the parentheses. But that's all distribute means is multiply. Okay? So you're not wrong there. So if I do this, okay. Now what do all of those terms have in it? Okay, they have a 3 and an n. So let's do this. Let's just take out the 3 out of all of those. Let's do it. So let's do it this way. Let me rephrase. Let's go. So 3 in. Best way to show my example. Let's do this. Let's go. Let's take the n out. So I'm going to take the n out of all these. Okay? Take an n out of that, and you'd be left with just 3, right? Take an n out of that one, you'd be left with just 3. And do that for all of them. Okay? Which now, that's kind of the reverse of distributing, right? Okay, so if I look at that n out front and I multiply it by each of those 3's on the inside of that parentheses, it's going to give me back the 3n plus 3n plus 3n plus 3n plus 3n, right? How many 3's do you have there? 5. What's 3 plus 3 plus 3 plus 3 plus 3? 15. And so now I have 15. I can simplify that to 15 and multiply that by my n, right? So there's a lot of maybe different ways of thinking about this. And that's ultimately the distributive property and then associative property here with the multiplication and grouping those 3's. But this here, if I just group those 2 first, it's a much quicker way. Does that kind of make sense? We'll talk about this again when we get into identifying the actual distributive property. Do I know what b is in that next one? You don't. So you don't know what to add 4 to, right? Okay. So that's kind of a bad grouping. So let's see if we can maybe do this. Let's take 4 plus 8 plus 7b. What if I did that? What allows me to do that? What did I do? What's the only thing I did here? I took away the parentheses, and I switched the 7b and the 8, right? What allows me to switch 7b and 8? Commutative property. Good. Okay. Now I'll put the parentheses back in. What allows me to put the parentheses, not there, put the parentheses around those 2 things? Careful. Commutative allowed me to move them. Associative allows me to group them differently. Now, even though my parentheses are in the same spots as they were at the beginning, they're around 2 different values, aren't they? In this case, they're around 4 and 8 instead of the 4 and 7b. But now, what can you do with that 4 plus 8? Add them together and get yourself 12 plus 7b. 12 plus 7b. That kind of makes sense? So the commutative property and associative property are allowing us to simplify things. What's that next one going to be? Well, we want to simplify it, right? So, what terms up there make the most sense to add together?
6 plus 3.
6 plus 3. So let's do that. Let's put the 6 and the 3 next to each other, and the 4h kind of on the end there. Does it make sense then to group those 2?
Yeah.
And what's 6 plus 3?
9.
Now, I don't know what h is, so I'm going to write plus 4h. That's the answer. Now, some of you might write this, which is perfectly fine. You might say, oh, he moved the 3 out there, or to the left. What if we did something like this? What if we take the 6 and move it to the back? Can I write this as 4h plus 3 plus 6 and group those? Is that okay? What's that math going to give me? What's 3 plus 6? 9. So I have 4h plus 9. And now the question is, are those 2, is that statement there and that statement there, even though they look differently, are they different? No. Why are they the same? What property says those are the same? Commutative property. Okay? So that's as we work through the year, guys. And I tell you an answer is 4h plus 9, or some intermediate step is 4h plus 9, but you wrote 9 plus 4h. I don't want you to think you're wrong, all right? Because of the commutative property and associative property, there will be different ways that I express something that might be different than what you have written down. But if you understand those 2 properties, you can make the determination whether you're following along or not. Does that make sense? Okay. That's the kind of one thing that's kind of a drawback I think about mathematics, is that there are alternative ways to write things, alternative ways to express things, alternative ways to solve problems. we come across problems, there might be 4, 5, 6, 7 different ways to solve them. If I only show you one of those in class, and that doesn't make sense to you, you're kind of stuck, right? So I'll try to show you as many as I can so that you can get yourself unstuck. But that doesn't mean that you can only learn and only be interested in the one that makes sense to you. You try to learn all approaches, because at some point, maybe approach B is the only option, but you've always focused on approach A, and you've never learned how to use approach B. Does that make sense? So if I look at this, I always put 4h plus 9, and then I see 9 plus 4h. I've learned it as 4h plus 9, and I'm never going to learn that 9 plus 4h is the same. Does that make sense? Okay, so let's go to the next one. The next one I want to kind of do kind of a side discussion here real quick about multiplication of fractions, which is usually a procedure not everybody enjoys. But if I took like 2 over 5 and multiplied it by, let's go 6 over 3. Do you guys know how you multiply fractions? Do you remember how to do that?
Cross multiply.
Not cross multiply. That's the number one wrong answer.
That was a variable. You only cross multiply.
You only cross multiply if there's a number on the left of the equal sign and one fraction on the right of the equal sign.
I forget. You just go across.
Yes, you go straight across the top. So what's 2 times 6? 12. And the bottom's 5 times 3, right? And that's the way most of us would write that. But is it okay to write this?
No.
Oh. Does that say the same thing Matt said?
Yeah.
Yeah, but I just put it into one fraction now, right? Because our laws of multiplication for fractions say we multiply straight across the top, straight across the bottom. So all I did is I didn't simplify it. I didn't say what 2 times 6 was. Okay? Now the reason I want to do that is because what if I gave you like 4/7 times, no, let's not do it that way. Let's go one fraction, 4 times 7 over 2 times 1. Okay, so now I'm giving you kind of this side right here, and I want you to come up with that side. Could you rewrite that as 4 over 2 times 7 over 1?
Yeah.
If I multiply it this way, 4 times 7, does that still give me top 4 times 7? Can I multiply 2 times 1? Now this is one that not a lot of people will write, but this is okay. Can I write this as 4 over 1 times 7 over 2?
Yeah.
4 times 7 still give me 4 times 7. Does 1 times 2, is that the same thing as 2 times 1? So those are equivalent ways of writing that. And now that understanding hopefully is going to allow us to solve this particular problem. Honestly.
Let's see about 7 times 4.
Say again?
Let's see about 7 times 4. No, it's just 1 and 2, not 4.
Huh? I'm confused. Right here?
Yeah.
What do you want me to write it as?
7 times 4 and then 1 times 2. You only put 2 times 1. And we're getting an example.
Yeah, I'm just showing that you could, but if I put the 4 and the 7, doesn't that give me the same thing I had here?
Yeah.
Yeah. But I just want to show you that these are still equivalent, even though I don't have the. So 4 over 2 is not the same thing as 7 over 2, right? And I wanted to show that that's okay to have, as long as I still multiply the top and get 28, and multiply the bottom and still get 2. The ordering doesn't matter. Does that make sense? So the reason for that is because now if I look at this, doesn't that mean I took 8 over 12 times maybe m over mn? Does that make sense? If I had those two fractions, you multiply those together, get 8m over 12mn. Make sense? Now we do one more thing. And leave this as 8/12. Can I write that m over m that way, and then times 1 over n? If I multiply the top, 8 times m times 1, do you still get 8m? On the bottom, do you get 12 times m times n? Does it 12mn? That make sense, everybody? So now, let's simplify. What number divides 8 and 12 evenly? 4. So we go in the top twice and the bottom 3 times, right? So 2/3. What's m over m?
1.
It's 1. Good. Okay? So no matter what, think about this, no matter what m is, it just represents a number. It was 6 over 6. 6 divided by 6 is 1, right? If it was 18, 18 divided by 18 is 1. So it doesn't matter what m is, you divide it by itself, that's going to go to 1. So it's multiplied by 1, which the multiplicative identity means the 2/3 doesn't change, right? Okay? And now 1 over n. Okay, so now if I multiply these three things together, what's 2 times 1 times 1?
2.
2. And 3 times 1 times n is 3n. That's the simplified version. Now, that's maybe longer than what we would normally do. Okay, if I was to give you this question in homework, maybe most people are going to say, oh, well, that 8 and that 12 reduces to 2/3, right? There's an m and over an m, so we're just going to cancel those because there's my 1. And I'm left with nothing up top except for that 2. So that 2 there, right? I'm left with a 3 and an n on the bottom. It gives me 3n. But I want you guys to recognize why you can do that canceling like that. Does that make sense? I think a lot of times, I want to fix it. I wish I was able to teach you guys from like 3rd grade all the way through till you graduate. Okay? Because I think the way sometimes that we're taught with the curriculum is that we're taught processes, procedures. You're shown how to do something, but you're never shown why until you get to the 9th grade, 10th grade, 11th grade. And you got to kind of reprogram yourself to think about what we're doing and why we're doing it instead of just seeing a process. Does that make sense? Okay? I don't want us to be kind of monkey see, monkey do. I want us to understand why we're doing what we're doing. Okay? And that's, we got to kind of reprogram our minds that way. Once we get that way, the math is not hard. Okay? And take it from somebody that's been in your seat. Okay? I was not a great 8th grade or 9th grade math student. Okay? Wasn't all that great 10th and 11th grade either. Okay? But once I started to figure out, instead of trying to learn a process, to learn the system, learn how things intertwine and interrelate and work together, then I became a better math student. And I got A's in every math class I took in college. Okay? Because I understood the system instead of trying to watch somebody do something and me repeat that. Does that make sense? Okay? And I want you guys to learn that the correct way so you don't ever land in that situation that I was in. If I didn't see somebody do it, I couldn't do it myself. Okay? All right, so these two questions here are based off of what we call deductive reasoning. Okay? If you see this up here, it says deductive reasoning is the process of reasoning logically from given facts to a conclusion, using previously known facts to argue a conclusion to be true. You do this every day. You do deductive reasoning every single day. Okay? The bell is going to ring. You know that for sure, right? That's a fact that the bell is going to ring, right? Because you've seen that in other days, correct? Okay? And then you are going to get up from this class, you're going to go to the 6th period, right? Because you know for a fact that that's what's happened before. Okay? So everything, I would say not everything, but most situations that you come across and how you react to them is based off of deductive reasoning. Knowing facts from the past and then using that to make a conclusion or an action in the present. So, these are questions that deal with deductive reasoning. Now, a counterexample is an example that shows a statement is false. In the last class, I used this analogy. Let's say that Mr. Fay has been an outstanding citizen, other than speeding tickets. He's been an outstanding citizen for his entire life. Okay? But today after school, I go rob a convenience store. Okay? What am I known as now for the rest of my life? A thief, a robber, probably a felon, right? Does that make sense? I was good for 35 years, not a mark on my record. But now one action negates those 35 years, right? And now everybody sees me as a felon and not a nice guy. Okay? That's the same thing we do in mathematics. If something's going to be true, it needs to always be true. If I'm going to be a nice guy, then I need to be a nice guy all the time, right? Okay? If I can find one example, one action of maybe being a burglar, okay, then that's going to make the statement that Mr. Fay is a nice guy false. Does that make sense? Even if after I've robbed the convenience store, then I'm a nice guy for the rest of my life, I was still a bad guy one day, and that makes me a bad guy. Does that make sense? That's the way people view things. So mathematically speaking, that's the same idea. This statement might be true for some values, but there are some values that it's false for as well. Okay, so that means that is a false statement. A times B does not equal B plus A. So find me a set of numbers that this would be true for.
2 times 2.
Good. 2 times 2 is equal to 2 plus 2. Okay, now it doesn't say that A and B had to be different, right? If I take 2 times 2, I get 4. I get 2 plus 2, I get 4, right? So that's true. But there are situations, let's say A was 1 and B is 3. Is that a false statement? Okay, so even though that was true, this is false. And one false statement makes this thing here a false argument. That will never be true. Does that make sense to everybody? Okay, and that's a counter, that 1 times 3 is equal 1 plus 3 is a counter example. Okay? You know, you've probably heard phrases, if it's raining out, then the grass is wet, right? Or let's say, if the grass is wet, then it's raining. Well, there's situations where the grass would be wet, but it's not raining. Does that make sense? Could the sprinklers be on? Could it be in the morning when it's got dew on the grass, that kind of thing? It wasn't raining, but the grass is wet. So those would be counterexamples to make that statement false. Okay? Just because the grass is wet does not mean it has been raining. This question here, look at those numbers. A plus B plus C, grouping A and B, is equal to B plus A plus C. Now I've repositioned things, and then I've regrouped. Let's choose some numbers. Give me a number for A.
1.
1. Give me a number for B.
2.
Okay. Give me a number for C.
3.
I heard 12 first.
No.
Okay. So this was A. This was B. That was C, right? I'm going to reposition them over here. So B you said was 2. A you said was 1. And C you said was 12, right? Do the math over here like the order of operations tell us. What's 1 plus 2?
3.
3. Plus 12 gives me 15. Over here on the right, order of operations tells me to do that first, right?
13.
2 plus 13. What's that give me?
15.
15. Is this true?
Yeah.
15 equals 15, right?
Yeah.
That's true. Are there any numbers that you can come across that you can play this game with that you would not get a true statement?
No, because it's
Okay, the answer is no, and you said it's because it's addition. And because addition carries what two properties? Commutative and associative. So because of the commutative property, because I'm allowed to take A, B, and C and move them around over here in addition, and because I'm allowed to take 3 objects in addition and group them by 2s any way I want to, the associative property, right? Because those two things are true, this will always be true. This statement is a fact because of the associative property and commutative property. Okay? There's an assignment in Math Excel 1.4. Most of it's asking you, here is a left-hand side of the equation. We've adjusted it. Here's the right-hand side. Identify the property that existed there. Was it the multiplicative property or the identity property, multiplicative property of 0, associative, commutative, that kind of thing. Okay? We'll talk about those tomorrow. And then the next 2 sections, guys, should go pretty quick. So I don't anticipate tomorrow taking the whole period to talk about 1.5. Same thing with 1.6 when we get to that. Remember, I know, like if you're using, I heard somebody talking about they were using these at the bottom. Remember, you can obviously, take your worksheet and type those in, those URLs, but those are also on my website. So if you go under section 1.4, those should be 4 links under my website 1.4 that you can access pretty quickly to practice these things. Okay? Bring questions tomorrow if we have them, and then we'll move on to 1.5.